Hello students, good morning. Welcome to my lecture for class 11 science, subject chemistry, Maharashtra State Board syllabus, chapter number 14 basic principles of organic chemistry. In the previous lecture we have studied about IUPAC nomenclature of organic compounds. Now today we are going to study the new concept, that is isomerism. Before going to study isomerism, let us see the activity. Here there are two structures, structure number 1 and structure number 2. Structure number 1 is what? CH3COCH3, and structure number 2 is what? C2H5COH, that is what? CHO. Now see, find out their molecular formulae. First we will consider this. How many carbon atoms are present? C3. How many hydrogens are present? 6. And how many oxygens are present? Only one, C3H6O. Similarly, for structure number 2, see how many carbon atoms are present? C3, hydrogen H5H, that is C3H6, and one oxygen. So they have same molecular formula. Now see, what is the difference between them? They have same molecular formula, but they have different functional group. Here CO and here CHO. CO means what? Ketonic group, and CHO means what? Aldehydic group. Now see, the phenomenon of existence of two or more compounds possessing the same molecular formula is known as isomerism. And see, in isomerism means what? The phenomenon in which two or more compounds having same molecular formula but different physical and chemical properties. Then the phenomenon is called as isomerism. Means two or more compounds, they have what? Molecular formula is same but they have different properties. That phenomenon is called as isomerism, and such compounds are known as isomers of each other. And there are two types. One is what? Structural isomerism, and other one is what? Stereoisomerism. Now let us start with structural isomerism. See here, when two or more compounds have same molecular formula but different structural formula, they are said to be structural isomers of each other, and the phenomenon is known as structural isomerism. And structural isomerism have different types. First, chain isomerism, second, position isomerism, then functional group isomerism, then metamerism, and last one is what? Tautomerism. Let us start with chain isomerism. See, in chain isomerism, they have different carbon skeleton. For example, C. This is one carbon skeleton. I will see another C. This is different carbon skeleton. See what happens here. Here, a parent chain contains longest carbon chain containing 4 carbon atoms, but here carbon chain contains only 3 carbon atoms. So here carbon skeleton is different. So what happens here? When two or more compounds have the same molecular formula but different parent chain or different carbon skeleton, it is referred to as chain isomerism, and such isomers are called as chain isomers. See the example: butane, CH3, CH2, CH2, CH3, and second one, C, 2-methyl propane. What happens here? See, CH3, CH2, CH2, CH3. It is one of the structure. See, they have molecular formula C4H10. Now see the second compound CH3, CH. Here you get CH3 and CH3. See here, it is 2-methyl propane. This structure and these structures, they have same molecular formula C4H10, but both the structures have different carbon skeleton. Now come to next point, that is position isomerism. Position isomerism is also a structural isomerism. And now see, position isomerism is related with different position of the same functional group on the same skeleton. See here, the phenomenon in which different compounds having the same functional group at different positions on the parent chain is known as position isomerism. See the example, but2-ene. See, CH3, CH3, CH, double bond CH, CH3. It is a structure of what? But2-ene. Here, after second carbon atom, 1, 1, 2. After second carbon atom, there is a double bond, so it is called but2-ene. Now see the second structure, but1-ene. Here, after first carbon atom, there is a double bond. So this is what but1-ene means. Here, the position of double bond is different, and therefore this is what example of position isomerism, and these isomers are called as what? Position isomers, and they have same formula, that is C4H8. See, 1, 2, 3, 4, H, 3, 4, 5, 6, 7, 8. So these are what? Position isomers. They have same carbon skeleton, but double bonds are located at different positions. It is about what? Position isomerism. Now come to the next group, that is next type, that is functional group isomerism. This is also structural isomerism. Now the phenomenon in which different compounds have or with same molecular formula have different functional group is known as functional group isomerism. See here example, CH3O CH3. That means what? Dimethyl ether. Means in dimethyl ether, ether is the functional group. But see the ethyl alcohol, that is CH3 CH2 OH, CH3 CH2 OH, in which OH is the functional group, but they have same molecular formula, that is C2H6O, but they have different functional group, that is one contains ethyl group and other contains what? Alcohol group. So these are the examples of functional group isomerism, and both the isomers are called functional group isomers. Now metamerism. Metamerism is also structural isomerism. Now see, different compounds with the same molecular formula and the same functional group, but having unequal distribution of carbon atoms on either side of the functional group is referred to as metamerism, and the isomers are known as metamers. See here, CH3 CH2O CH2 CH3. See, in ethoxyethane there are two carbon atoms on either side of oxygen atoms. See, the left hand side of oxygen atom contains two carbon atoms, as well as right hand side of oxygen atoms having two carbon atoms. But in methoxypropane, on left hand side there is only one carbon atom, and on right hand side there are three carbon atoms. So they have same molecular formula C4H10O, they have same functional group, that is ether, but there is a unequal distribution of carbon atoms attached to oxygen atom. In ethoxyethane, there is equal distribution of carbon atoms, but in methoxypropane, there is unequal distribution of carbon atoms. So these are metamers of each other. Now next, that is what tautomerism. See, same compounds exist as mixture of two or more structurally distinct molecules which are in a rapid equilibrium with each other. This phenomenon is referred to as tautomerism, and such isomers are called tautomers. Now see the example. CH2 double bond CH OH. It is called as vinyl alcohol. Vinyl alcohol. And see, if we are writing CH3 CH O, these are tautomers. See what happens here. Vinyl alcohol contains OH as the functional group, but in acetaldehyde, that is CH3CHO, aldehyde group is the functional group. Now see the number of carbon atoms. C2 H4 1 oxygen. Similarly, C2 in acetaldehyde C2 H4O, means both the structures, that is vinyl alcohol as well as acetaldehyde, both have same molecular formula C2H4O, and here this functional group is modified. Functional group is what? Modified. And so this is the example of tautomerism. Now see, isomerism are of two types. First one, structural isomerism, and second one is what? Stereoisomerism. We have completed about structural isomerism. Now come to what? Stereoisomerism. Stereoisomerism is the phenomenon in which two or more compounds having same structure formula but different spatial arrangement of groups. This phenomenon is called as stereoisomerism. And there are two types. One is what? Geometrical isomerism, and second one is what? Optical isomerism. We have to study that in detail in the next chapter. So we have completed isomerism and their classification. Thank you very much. Go through the examples we have studied. Thank you very much.